Hello everyone and welcome to this video. We're going to jump right into it. This is a lesson on learning TypeScript. We are going to cover type annotations and basic types, some very simple introductory types for TypeScript. Well, the first one we might have is string. Right? You're all familiar with strings. They are a series of characters. Let's go ahead and change that to let for the moment. Here we have a string of a first name you're all familiar with. And we want to point out that this is the TypeScript part. This type annotation here after the colon. So this is the part that is not part of JavaScript. And if you hover over in VS Code the variable, you will see that it is also included in this little tooltip right here. Let's go ahead and introduce other types we might be familiar with, introducing numbers, and we'll introduce booleans, true or false values. And you'll see the same thing here. If I hover over age, it tells me it's a number. If I hover over is member, this true or false is characterized as a boolean. Now here I'm using the let keyword instead of the const keyword. If I go ahead and change this, something interesting happens. If I then save this and I remove the type annotation, what happens is this is no longer a string, but this is a very specific string, the string John. So why did this happen? And also I can demonstrate this with the number here. Let me remove the type annotation from these. And if we hover over, we'll see it's still number, but I'll change these to const, and we will see that in fact, it's the more specific number 42, and it's the more specific Boolean true. What's happening here? Well, what's going on is something called type inference. So if I don't explicitly declare this as a string, TypeScript is going to infer the type from what I assigned it. So it's going to assume this is John. It's John because it can only be the string John. If I change it to let, which would let me later reassign this to a different value, then the type must be any possible string and not the specific string John. And we can see that holds true if I change this to let again. It's on any number, and this is any Boolean. What we've seen is a type can be what's considered a wide type, like any string, or a very specific string in the case of if you're using const. Okay, so you can think we have wide types, like general data types, like string, number, Boolean, and we can also have specific types that are very specific instances of those wider types. We'll talk about this later, but this is also called these are literal types. So this would be a string literal type. Cat. And then the inference part means I don't have to specifically state that this is a string. TypeScript will infer it for me so I can save some keystrokes. Now there are some other less frequently used primitive types. In this case, I'm going to introduce the symbol, okay? So this is, instead of a string, it's a symbol, and you can use this to be keys in objects, but you don't see it as often. But if you hover over here, you'll see it says symbol. And if I let it infer, it'll be the type of this symbol. We'll get into the type operator later. And another primitive type is the big integer. So there's a weird caveat, or there's a caveat here that you have to have a certain version of TypeScript or be targeting a certain version of JavaScript, but the big integer is another type you might see. So building on this, we also notice, or we can also see that functions and various parts of functions also have types. So I've got this tsignore comment here. If I remove this, what we will see is that this part is complaining. It is going to implicitly have the any type, which we'll talk about shortly. And TypeScript is saying that this is a bad practice. You want to either explicitly say it's any or give it a type. But this is what you would have in regular JavaScript, right? You wouldn't necessarily have this type annotation here saying that first name must be a string. And so what happens is if someone is using your function, now maybe you made this function, so you know it has to be strings. So on a small project, this might not be an issue. But when you work with other developers and as your code gets more complex, you might want to make sure that they can't do something like enter an incorrect value here, right? Notice this is not telling me anything is wrong, but clearly it is not going to be able to add this object to this string in a way that makes sense. So what can we do to prevent this very common set of bugs where we use or we pass the wrong thing into a function that was not designed to handle that? By the way, if you hover over the function, you can get the type signature here, which is telling you this parameter is of any type, and it's returning an any. We'll go into return types very shortly. But I can get, while I'm writing my code, help to reduce this error by giving my function parameter type. So I can say that first name must always be a string. This function is designed to only add 2 strings. And so now you've seen that it gives me this red squiggle, right? So this, the type of the thing we are trying to put into our function, is not assignable. It doesn't fit, or it doesn't match the type string. Notice also it will not allow me to type in a number. It will allow me to type in string, even if the string is the number 42, so to speak. But if I type in 2 strings, it's now happy. It no longer tells me an error, and I've immediately get feedback on whether the code I'm writing is correct or not, instead of having to run my application. All right, so what we just did was we added these type annotations to our parameters. And so this is these are called parameter types. There was also this little bit that we saw briefly at the end of our function, right? So this is the return type of our function. Functions typically return values. In this case, we are designing our function to always return a string. So in this case, it's happy. If I had said this function must return a number, it will tell me we have written some code wrong. It is not returning a number. If I add the length property to calculate the length of these 2 strings and return them, then now it's returning a number, and TypeScript is once again happy. So it's often a good idea to explicitly put return types in your functions. This will tell you if you had made a mistake in your code somewhere. You can also let it infer it. If it's a simple enough function, you can just leave it off. And if you hover over the return type, if you hover over the function, you'll see that it is inferring the return type. And if we store the value of our function, that return type gets assigned to the variable we're storing the result in. Now, to build upon this more with functions, if we take what we are calling the parameter type, and then we take what we're calling the return type, and we combine them together, we'll get a type for the entire function. So I can use the keyword type, and I can give it a name function, and I can use the arrow syntax to say that this function must return a string, and that each parameter is also going to be a string. So once I've created this type, I can use arrow syntax when I want to store a function in a variable. So my function here, I can use the colon here. I can say that my function is going to be of type name function. And then I can begin the setup with how I would write a function using the arrow syntax. So right now this function is not correct, or it doesn't match the type, and I will get suggestions here from TypeScript. So the current type, where it has no parameters and it returns void means it's returning nothing, right? Nothing's explicitly being returned, is not assignable to type name function, because returning nothing is not the same as returning string. So if I return a string, my function now passes. Now what we didn't use either of these return parameters, but I can still use them, but I can't use more than what's specified in my type. So this is saying parameter C doesn't match, right? This type signature here does not match name function. I reduce it to the correct number of parameters. I can then create my function, but I cannot use these any way I want, because it knows these are strings, and you cannot multiply 2 strings in this way. So it knows they are strings, even though we didn't give them a type, because it is picking that up from this type annotation. So it knows that the first parameter must be a string, and this second parameter must be a string as well. Notice the names of the parameters in your type definition do not have to match the names of your parameters when you're actually implementing or defining this function. So I also want to point out, while we have this code here in front of us, that these parts that are TypeScript disappear when you compile this into JavaScript, which is necessary before you run it in the browser or in Node.js. So on the right, we have what the compiled output looks like. You'll notice these functions no longer have their type annotations. This entire line here on line 14 goes away because it doesn't exist. And we also have this addition of this use strict in our JavaScript. So I'm re-emphasizing the point that the TypeScript parts don't exist in the JavaScript code once you compile it. They are only going to work while you're editing it in your editor and while you compile it. Okay, let's go ahead and cover the any type and a few others. So if we go back to the example of we are creating a string, this will let me reassign it, but I will not be able to reassign it to something that is not a string, right? Number is not assignable to string. I can also not give it a Boolean. But if I give it the value any, then what happens is you are basically telling TypeScript that you don't need the help of the type system. You are opting out of it. You are telling it that you know what is going on and that you're okay with it. You are taking responsibility for this code executing correctly at runtime. So the rule of thumb is, in general, you want to avoid the use of any, although there are areas where if you're confident, you can use it and save yourself some time. If we go back to our code here and we change both of these results to any, you will see that this then allows me, it will permit me to multiply these together, even though at runtime, if I'm putting a string in here, this will result in some sort of error. Some other common values we might see are undefined. So if we hover over here, this is going to be of the type undefined. Actually, let me make sure by making it a let. So actually, it's going to give me the any type. It's going to infer the any type. I can also explicitly give it the type undefined, in which case this is not really something you would do, but it would prevent you from assigning other things. If I change this to null though, this usually, interestingly enough, this actually did seem to work. However, you wouldn't usually do this because of the type of null. Oh, it's because this is acting as a type literal. Okay, so the type of null is usually object. So if I remove this inference would either be any, or actually if you did type of myvar, I'm gonna need to add console log here so that we can actually see the results. All right, so now if we run this, you'll see that we actually get object. So the type of null is object, which is a little unintuitive, but it's important to remember. If we save this and we want to figure out what type of undefined is, we actually do have a separate undefined type. So those are just some things to keep in mind. And we'll talk more about undefined and null when we talk about optional types and more complex types. Okay, that's going to be it for this chunk of lesson on learning TypeScript. I hope you enjoyed it. I hope you found it useful. If you enjoyed it, please click the like button. If you want me to create more of these videos, clicking subscribe helps a bunch. In the next video, I believe the next video on TypeScript, I believe we're going to cover some more types such as unknown, never, records, which are like maps or objects, although map is a separate thing. So these are compound types. These are going to build on our more primitive types like our numbers, strings, and booleans. We're going to introduce optional types, things like that. We're also going to look at the type versus the interface keyword. We're going to look at type of versus instance of and optional properties. So I hope to see you in that one.